Okay, there's one problem we skipped earlier, and we are going to lead into section 3.6 here in a second, which is on page, 341. But I want to go back to this one. I didn't cover it in the previous video, but I want you to look. If you do the kind of change in y over and change in x, if you notice they're going down and then going across this way, that if you take the change divided by the change, or the change divided by the change, change divided by change, this one's not consistent. So this one's not linear. But if you look at this one's going up by 5, up by 5, up by 5. And these are going what? Up by, I think it's 17. Does that look right? I think, hopefully I'm right there. Up by 17, up by 17. And so this is definitely linear because it's a constant amount. And again, think back when we did arithmetic sequences and linear. We've done this before. This is kind of review. The only thing that we're going to work on now is writing the equation, but you kind of know how to do that. You guys have written equations on previous exams. So you have y equals, and then remember we have our starting amount, which in this case, remember everything in real life starts at 0. So maybe someone's in debt $140. And then what is the rate? How is it? What's the constant increase? Well, it's going up by $5 all the time. And your rate always has to go by a variable because, you know, is it going up once, twice, 3 times, 4 times? That's where your variable comes in. So you have done this before. We're just kind of hitting it from a little different view, but it's still the same math that you did when you did arithmetic sequences and linear growth, you know, in chapter 2 or cycle 2. All right, let's go ahead and pause and turn to page 341, section 3.6, and we'll pick up there. Go ahead and try to do the explore. So number 1, A through D, and then, so go to that page, pause the video here, try it on your own, and then we'll go through it together. Okay, so let's go through this together. And again, my goal is to have you try these on your own first, just because that's how your brain grows. You don't always, your brain doesn't grow when someone else shoots the free throws. It grows when you shoot the free throws, or at least physical growth. We're talking about mental growth here. But, all right, so hopefully by this point in the class, you realize you know way more than you think you know. We have done this. We're just looking at it at a different view to get it deeper into our brain. So here's a function. You have your input and you have your output, or you have your independent variable and you have your dependent variable. All concepts we've talked about. So if I sub in 0 into the formula, so 4 times 0 is 0, I get a grade of a 62. Put 1 in there, I get a 66. 2 hours in there, 8, looks like a 70, and you can just go ahead and continue to fill out that chart. So you just sub in 4, sub in 5, you should get, if you sub in 3, you should get 74, if you sub in 4, you should get 78, sub in 5, you should get 82. And notice then, if we answer these questions here, and it's hard for me to write in these little blanks, so the exams increase by 4 every time the person studies what, 1 hour, okay? So we can see that the slope is 4 over 1, right? Which is 4. And it is definitely linear because it's constant, right? It's going up a constant amount. Since 0 study hours leads to an exam score of, let's see, what would that be? A 62 if they don't study at all. So they must have some type of background knowledge in this. Then we know that our initial value is at 62. Oops, that doesn't look like a 6. So again, you could have written this equation. Had I given you this chart, you should have been able to write the equation. So y equals, you look and you're like, oh, it's going up by 4 all the time as these are going up by 1. So you know the slope is 4 over 1. Oops, sorry about that. So you know the slope is 4 over 1. So that is your constant increase. And remember when we did arithmetic, it would be like 4n. We're just using x. And our starting amount is 62. So maybe like I've taken tons of psychology in undergrad and in grad school. I don't know, I could maybe even teach psychology. I have a lot of background in that with ed psych. And so if I just took a Psych 101 and I didn't study at all, maybe I could get a 62 because I have some background knowledge. But for every hour I study, my grade's going to go up 4. So then I could use this formula. If I study, say, 10 hours, it looks like I would get, what, 102%. So maybe if there's extra credit, but I'm sure this formula cuts off at a certain point. All right, so again, we're just tying everything you have learned in the past together, kind of in a nice little bow, or at least that's the goal, is to just give you a chance to kind of see how everything you've learned is just interconnected. All right, so to graph then, you have a starting amount at 62. Now this isn't going to be perfect with me graphing with a finger here. And then notice your slope is 4. So you would rise 4 and run 1, which looks like it's rise there. Run 4, rise 1, over 4, over 1. And again, if you hate graphing that way, so again, what I'm doing there is I'm using my Y-intercept, which is my starting amount, and notice it's on the Y-axis, so that's why we call it the Y-intercept. Okay, interception football is when someone crosses over and grabs the football from another team. So this is where it crosses the Y-axis, is the Y-intercept. And then I can use my slope as my rate of change. So I'm going to rise 4 on the Y as I run 1 on the X. So notice they were nice and went by units of 4 and so forth. The other thing is, if you're like, Julie, I hate this, well, that's okay. You can always make an input-output chart like you did up here, and you can just plot these points. So if you don't like, you know, kind of using how the formula works, then go ahead and make a chart. Just remember in your formula, this is a point. 0.62 is an actual point. The slope is like a factory. It's a point maker. It is not a point in and of itself. It's your rate, and it just creates other points. And again, I'm sorry, that's not going to be a great line. But if you guys plot it, use a ruler, you're going to have a much nicer line than I do. All right, go ahead and read the next page, and I will pick up with you on problem number 2 on page 343. Try page 343, number 2 on your own. Read everything in between, and then we will pick up there. Okay, so let's go ahead and look at this one here. See if I can get a pen. All right, so if my input, again, I have, again, no pen. Review. And every single time I have to do this, I apologize. Can I write? There we go. Okay, so this is my input, and this is my output to my function. So if my input is 0, I'm going to get just 4y equals 12. To get rid of multiplying, I'm going to divide. So I get 3. And then I could sub in 1. So then I get 2 plus 4y equals 12. Subtract 2. 4y equals 10, divide by 4, and you can either write a decimal, you could write 5 halves, you could write 2 1/2, something like that. But notice this is a lot of work. The even ones aren't going to be so bad. Those aren't going to give me fractions, but it looks like the odd ones are. And so sometimes in math, we're just like, you know what, that form, that's called standard form of an equation. It is not super helpful. It exists because you can imagine back in the day before they had computers, typing this was a lot easier than trying to type fractions. So it was more of a logistic issue historically to type it nice into a book before computers, and even with typewriters, fractions were a problem. So in math, sometimes it's like, well, it'd be easier if it was in y equals form. So we're going to go ahead and we are going to solve this for y. All right. And so again, think about what math is in here. There's only one adding in here. And so I'm going to go ahead. I want to keep my y on one side and get my x and other stuff to the other side. So to get rid of adding 2x, I'm going to subtract 2x. And I get 4y equals, and I'm going to write it in y equals mx plus b form. So I'm going to put the x part first and the y later. Right? And now my goal is to solve for the y part. Where's my, again, sorry. This is kind of slow using my finger here. So to get rid of multiplying by 4, I would divide by 4. And again, I'm going to divide everything by 4. You can't just pick and choose what you want to divide by 4. This is a negative 1/2. And then 12 divided by 4 is 3. Okay. Now, why do I like this better? Well, because now I have more conducive to input and output. So notice if I shove in 0 here, sub it in, I get 3. If I sub in 1, do you see how you can use your calculator now? So if I sub in 2, now I can just type this on my calculator, right? And I can just get a pretty quick answer. Otherwise, I could do it, you know, if I remember how to kind of do my fractions here, I could just do it myself. So solving for y so that you can fill in the formula or fill in the chart is super, super easy. You just type it in your calculator. So like for again, with 4, I would sub in 4. I could get a negative 2 plus 3, and that's where my 1 came in. And then I have, what, a half and 0. All right, so I can fill this out. Now, if I want the equation for this, I can do that as well. So I solved for the equation. So this is called y equals mx plus b form, or slope-intercept form, because do you see how you can see the slope and you can see the intercept? But the other thing I can do is, if I just had this chart, I could still write the equation. Y equals my slope and then x, and then my starting amount is always at real life at 0. There's my 3. And so I can look at this and be like, okay, what's happening here, right? And it looks like every single time it's going down by a half. So if I just had the chart, I can write the formula. If I have the formula, I can fill in the chart. And so everything is just very nicely interconnected. Okay, and then the question is, what is your slope? Well, your slope is your rate. So that's a negative half. That's this guy right there. And what's my y-intercept? Sometimes people say b equals 3. Sometimes they write it as an ordered pair, so 0, 3, because it's on the y-axis. So that would be what I have. Now, the x-intercept is where it crosses the x. That doesn't really help you as far as formulas go, but that would be this number down here. There's your x-intercept, because the number's on the x spot, so that's where it crosses the x-axis. This is your y-intercept. This one doesn't really help you write equations. Okay. All right. I'm going to pause there. Let's see, where are we going from here? Let's go ahead and go to the next page. Read example 1 and then try number 3 on your own, and that's where we will pick up. Okay, so again, let me make sure I can write. If there's this video in your book, there are publisher videos where they paid people money to make the videos, and I'm sure they are way more talented than I am. So feel free to watch those instead of myself, and you will probably maybe have a better experience, but I'll do my best. All right, so what do we want here? We want the slope and the y-intercept. So think about, again, when you graph, where it crosses the y-axis is the y-intercept. That's a point, and then your slope is kind of how it changes. It's the rate. So again, if I have something like this, this is my y-intercept, and then my rise over run, that ratio is, or the rate of change, that's your slope. So one is a point, one is not. So if it is in y equals mx plus b form, then the nice thing is this is always your starting amount. That's your y-intercept. This is always your slope. That's your point creators. So this one is nice. So they want the y-intercept and an ordered pair. So my y-intercept is 0, 2.5. And again, write it as an ordered pair. My slope is negative 6.5. And that's not a point. That's just a point creator right there. That's supposed to be a decimal, but I can't write it very well. All right, let's look at the next one. Technically, this next one, there is a plus 0 at the end. I'm going to erase that so we have more space. So again, technically, there's a plus 0. And in addition, there's a 1 as a coefficient in front of that x. So hopefully you can see that the slope is a negative 1/3. And the y-intercept is 0, 0. So that line is going to go through the origin. Right, and it's going to have a negative slope. So it's going to, what, rise 1, go backwards 3. So kind of like that, okay? The next one, notice here there's no x. So in a sense, it's 0x plus that 4. So this one has a y-intercept of 4. It's going to cross at 4, but it's going to have a slope of 0. So think back when we talked about slope and kind of what's going on there, like can you ski on the line, can you not ski on the line, that whole conversation. So if I have a XY axis here, Y is stuck at 4, so it's right here. So if you think of your skier, right, can they ski? Yeah, cross country, it's kind of boring, but they can ski. So it has a slope, the slope is 0. And we have a y-intercept, it crosses at 4, but we're just kind of stuck there. So that would be a horizontal line. All right, the next one, your number that's all by itself, your constant is your b. So this has a y-intercept of 100. And then the slope, the negative 2 goes with her. So the slope is a negative 2. And notice when we write the slope, we don't put the variable. It's just that coefficient. All right. So again, sometimes students like to turn it around so they can see it better. But as long as you know that the thing that is by itself is the starting amount and then the multiplier is your slope, you should be good to go. All right. we're going to finish here. Go ahead and read the next example, and then we will pick up from there.